Begin from a supply chain anomaly inside defense procurement logs rather than a geopolitical headline. Build a cause and effect chain through industrial choke points rather than a chronological history. The real leverage in rare earths is not resource ownership, but midstream separation and magnet manufacturing capacity. Mood applied, cold and analytical. In late 2023, a quiet issue started showing up in US defense procurement conversations that didn't look dramatic on paper. It wasn't a weapons shortage in the usual sense. It was magnets, permanent magnets, the kind you don't notice until they disappear from actuators, radar systems, missile guidance assemblies. At first glance, that sounds almost trivial, but it isn't. Not when you trace what those magnets depend on. And that's where China enters the frame. Not as a headline, but as a structural presence in the material backbone of modern defense systems. My read is simple. The tension around rare earths has never really been about mining. It's about control over transformation, turning rock into usable industrial force. Let me explain what that actually means in practice. China didn't just become a large producer of rare earth elements. Over roughly 2 decades, it built dominance across the midstream layers that most countries quietly outsourced: separation, refining, alloy production, and most critically, neodymium iron boron magnet manufacturing. Estimates from multiple industrial studies and US Department of Defense assessments consistently place China at roughly 60% of mining output, but far more importantly, closer to 85 to 90% of processing and magnet production capacity. That gap between mining and processing is where leverage lives, because raw rare earth ore is not what defense contractors need. They need finished magnetic materials with extremely tight performance tolerances. That requires chemical separation facilities, solvent extraction know-how, environmental handling capacity, and scale efficiency that is hard to replicate quickly. So when people talk about a ban, it's rarely a single switch being flipped. It's more like tightening valves across a pipeline that most of the world forgot it was dependent on. We saw a version of this logic back in 2010 during the China-Japan rare earth dispute, when export quotas tightened and prices spiked almost overnight. But what's different now is the integration into high-end defense manufacturing. Modern systems like the F-35's control surfaces, precision-guided munitions, and radar assemblies rely on compact, high-strength magnets that don't have easy substitutes without redesigning entire systems. And redesign is slow, sometimes measured in years, not months. Here's the part that complicates the narrative. China doesn't even need an outright ban to create pressure. Export licensing delays, environmental inspections, or selective quota adjustments can produce similar downstream effects. The system reacts before the policy is fully visible. That's where a question starts to matter more than the headline itself. What actually counts as restriction in a supply chain where timing is the real variable? Because if a defense factory in the US waits 6 months for a critical magnet batch, the operational outcome looks very similar to a formal export cutoff, just less politically visible. And this is where I think most analysis misses the point. The vulnerability isn't just dependence, it's synchronization. Entire defense production lines assume that upstream materials arrive on predictable schedules. When that assumption breaks, the system doesn't fail loudly. It degrades quietly. A partial forecast here is fairly straightforward. The United States and its allies will keep investing heavily in domestic rare earth processing capacity. We're already seeing announcements tied to Department of Defense funding and partnerships in Australia and North America. But the bottleneck will likely shift rather than disappear. Mining can be diversified. Processing chemistry and magnet-grade production scale is a slower problem. And that leads to a less comfortable possibility. Even with new mines, the strategic pressure point may remain concentrated in a relatively small number of chemical separation facilities globally. So the real story isn't about a dramatic ban that shuts factories overnight. It's about a system where small administrative decisions in one part of the world ripple through assembly lines in another, with delays that only become visible when delivery schedules slip. And the question I keep coming back to is this: If a supply chain only fails gradually, at what point do you call it dependence versus control? There's a temptation in Washington policy circles to treat this as a solvable procurement problem. Build a mine in Nevada, fund a refinery in Texas, sign a few agreements with Australia, tick the boxes, reduce exposure, move on. That framing sounds clean because it matches how industrial policy is usually discussed: inputs, outputs, investment, timeline. But rare earths don't behave like that anymore. If you zoom into the production chain, the uncomfortable reality is that rare earths are not rare in the geological sense. Cerium, lanthanum, neodymium, they're relatively abundant. What's rare is the ability to isolate them at scale without environmental blowback and at price points that don't collapse downstream manufacturing. And that's where China's advantage stopped being about geology decades ago and became about industrial patience. Take Baotou in Inner Mongolia. It's not just a mining region. It's an entire ecosystem built around separation plants, tailings processing, chemical waste management, and magnet fabrication clusters. Over time, that density created something that is very hard to replicate: feedback loops between chemical engineering, labor specialization, and scale economics. You don't rebuild that with capital alone. You rebuild it with time behaving in your favor for 20 years straight. Now contrast that with the US experience. The Mountain Pass mine in California is often cited as the comeback story of domestic rare earth production. And in a narrow sense, it is. But for years, even Mountain Pass had to send a large portion of its material to China for processing. That detail matters more than the headline output numbers, because ownership of ore without ownership of refinement is not independence. It's dependency with extra logistics. This is where the defense angle becomes sharper. A modern precision-guided missile system isn't just steel and explosives. It's sensors, miniaturized motors, and high-torque magnets operating under extreme thermal and vibration constraints. The tolerances are tight enough that even small variations in magnet composition can affect reliability. So when supply chains shift, even slightly, the risk doesn't show up immediately as "we are out of stock." It shows up as requalification cycles, testing delays, recertification of components, engineering workarounds. And that's the silent cost most people don't model. There's also a political layer that complicates things further. Export controls are often discussed as if they are binary, allowed or blocked. But China's rare earth governance has increasingly moved toward a more selective model, licensing requirements tied to end use, destination, and sometimes even corporate compliance behavior. That introduces uncertainty rather than outright denial. Uncertainty is harder for industry than prohibition. Prohibition is at least legible. You can redesign around it. Uncertainty forces overstocking, redundant sourcing, and inflated safety buffers across defense contractors like Lockheed Martin and Raytheon. That ties up capital and slows production cycles even without a formal cutoff. So when the phrase rare earth ban circulates in media discourse, it misses the more important mechanism. The power isn't in flipping exports off. It's in making them conditional, variable, and time-sensitive. And here's a historical reference that often gets simplified. During the 2010 dispute with Japan, prices for some rare earth oxides reportedly spiked by several 100% in months. But the deeper impact wasn't price alone. It was the realization among industrial planners that just-in-time manufacturing assumptions could be disrupted by upstream policy shifts in a single jurisdiction. That realization never fully went away. It just got absorbed into supply chain modeling. Which brings us to today's strategic dilemma. Even if Western economies successfully rebuild parts of the rare earth pipeline, they are entering a system where the most complex stage, heavy rare earth separation and high-performance magnet production, still remains heavily concentrated. And concentration doesn't need to be absolute to be influential. It just needs to sit at the right choke point. A question starts to surface here, and it's not a rhetorical one. If a country controls the most fragile step in a chain, does it need to control the entire chain at all? because in practice, controlling the bottleneck often behaves like controlling the system. And that idea becomes harder to ignore as you move deeper into defense manufacturing schedules, where delays don't just affect profit margins, they affect deployment timelines. There's a detail in defense manufacturing that rarely makes it into geopolitical commentary because it feels too technical to matter. But it matters more than most headlines. A modern defense program doesn't run on availability. It runs on qualification. Every component, especially something as sensitive as a high-performance magnet used in guidance systems or radar actuators, has to pass certification cycles. Not once, repeatedly, under different environmental conditions, different batches, different suppliers. Now imagine what happens when the material input for that component shifts even slightly because the upstream refining source changes. Same chemical name on paper, different impurity profile in reality. That's where timelines start to stretch without any formal ban ever being announced. And this is where the China question becomes less about trade and more about industrial architecture. Official U.S. Defense Logistics Agency assessments over the past few years have repeatedly flagged rare earth supply chains as high risk, not because supply is absent, but because substitution pathways are not mature. In other words, alternatives exist in theory, but not in production-ready scale. That gap between theory and scale is where strategic vulnerability lives. Now, to be fair, there's a counter-argument that deserves attention. China also depends heavily on rare earth exports for certain downstream economic sectors and foreign revenue. And overusing export restrictions risks accelerating diversification away from its own supply chain dominance. That logic is correct in theory, but it assumes symmetry of adaptation speed, and supply chains are rarely symmetrical. One side is trying to build redundancy under political pressure. The other side already built redundancy into dominance by becoming the default processor for most of the world's output over decades. That asymmetry is subtle, but it compounds. Let's add a concrete layer here. In 2023 to 2024, global demand for neodymium iron boron magnets surged, driven not just by defense, but also by electric vehicle motors and wind turbines. Forecasts from agencies like the International Energy Agency suggest demand for some rare earth elements could increase multiple times over by 2040 under clean energy transition scenarios. That means the bottleneck is not static, it's expanding under pressure. So even if Western countries succeed in duplicating existing capacity, they are not entering a stable system. They are entering a moving target. And moving targets are harder to decouple from. There's also a quieter industrial reality, environmental permitting. Rare earth separation is chemically intensive. Acid use, radioactive byproducts, wastewater management, all of it creates regulatory friction in countries with strict environmental standards. China absorbed much of that environmental cost domestically over years of rapid industrialization. Other countries are now trying to rebuild capacity without replicating that environmental trade-off at the same scale. That slows everything down. Not because of lack of money, because of legal and social constraints. So when analysts talk about reshoring, the timeline often assumes linear scaling. Build plant, increase output, reduce dependency. But chemical processing capacity doesn't scale linearly. It scales in clusters. It requires supplier ecosystems, waste management infrastructure, trained chemical engineers, and downstream buyers willing to commit to long-term contracts. Without that, facilities become underutilized or economically unstable. And that brings us back to defense factories, because they don't wait for ecosystems to mature. They operate on procurement schedules tied to operational readiness, aircraft production slots, missile replenishment cycles, naval maintenance windows. If rare earth inputs slip, the adjustment doesn't happen at the mining level. It happens at the assembly line, slowly, then all at once. There's a final tension here that I don't think gets enough attention. China's leverage in rare earths is not purely coercive, it is structural. It emerges from decades of investment decisions that aligned processing capacity, export policy, and industrial clustering into one dense system. And systems like that don't collapse cleanly. They don't turn off. They reroute pressure. Which leads to a harder question. If the world successfully diversifies mining but not processing, did it actually reduce dependency or just move the choke point one layer deeper into the same architecture? There's a habit in geopolitical forecasting that I'm not fully convinced by anymore. It treats supply chains like maps. If you redraw enough lines, the vulnerability disappears. But rare earths don't behave like cartography. They behave like chemistry under constraint. And chemistry doesn't care about intent. By this point, the real picture is less about China shutting down anything and more about something structurally quieter. A system where a small number of processing hubs sit between raw extraction and usable defense-grade materials, and where those hubs accumulated over time because they were economically rational at every step along the way. That's the uncomfortable part. Nothing here required a master plan. Now, I want to be careful with the word control, because it gets overstated. China doesn't need to micromanage global defense production to matter here. It only needs a high share of the most technically demanding transformation stages, heavy rare earth separation and sintered magnet production. The rest follows from that position. And we already saw how that plays out in practice during earlier trade tensions. Not a full cutoff, not a global shock, just selective tightening, licensing friction, and timing variability that cascades into downstream scheduling problems for manufacturers who are used to predictability. Predictability is the real currency here. More than price, more than volume. Now, my own view is that the next phase won't look like a dramatic embargo at all. That's actually less likely than most headlines imply, because outright bans accelerate substitution. Instead, what I expect is continued precision governance of critical mineral exports, tightening around end-use categories, more scrutiny on advanced manufacturing applications, and periodic recalibration of quotas that keeps buyers permanently uncertain about future availability. Not a wall, more like a gate that changes shape every few months. And that's harder to plan against. At the same time, Western industrial policy is not static anymore. The US Department of Defense has already begun funding domestic magnet production initiatives, and partnerships with Australia's Lynas Rare Earths have expanded non-Chinese processing capacity. That direction is real. It's also expensive, slow, and uneven. The part that gets underestimated is time, not technology. Even if every announced project succeeds, you're still talking about a multi-year lag before meaningful redundancy appears at scale. And during those years, demand doesn't pause. Electric motors, radar systems, missile production lines, they keep pulling on the same constrained inputs. So you get overlap. Old dependency structure still active, new structure not fully online yet. That overlap is where risk concentrates. I'll stake a simple prediction here. Over the next decade, the global rare earth system doesn't decouple. It rebalances unevenly. China's share in mining may fluctuate, but its influence over processing and high-performance magnet output will likely remain disproportionately high compared to its raw material share. Not because others fail, because scaling chemical ecosystems is slower than strategic urgency. One more thing I keep coming back to, and it's not comfortable. Even if the West eventually achieves full industrial independence in this sector, the transition period itself becomes strategically meaningful. Because defense planning doesn't operate on end states. It operates on what is available during the ramp. And during the ramp, vulnerability is highest. So the original question, whether a rare earth ban could shut down defense factories, misses the deeper mechanism. It doesn't require shutdowns to matter. It only requires friction at the right point in the chain, sustained long enough to distort schedules. And that brings me to the final thought I can't fully resolve. If global manufacturing systems now depend on a handful of chemically complex bottlenecks, is the real competition between countries, or between the speed of industrial scaling and the speed of geopolitical tension? No clean answer to that yet. But I don't think we're looking at the end of rare earth leverage. We're looking at its normalization. If this continues on its current trajectory, my prediction is simple. Rare earths stop being discussed as a crisis material and start behaving like a permanent background constraint in defense planning, something every procurement cycle quietly budgets for, even when nobody is talking about it publicly. And maybe that's the real shift, not disruption, but permanence. If you want another deep dive like this, say the topic, and I'll build it from a completely different structural angle.